This video will focus on the cubic parent graph whose equation is y equals x cubed. As you take a look at the graph, it is very unique from the others in that it's kind of like this almost an S-shaped type curve where it curves down and then curves back up. Now that point where that change occurs, where it's curving down here and then it changes to curving back up, we call that the inflection point, and that's what HK is. So your locator point is always at HK, and it's the terminology we use is the inflection point. That's a calculus term, which will be defined more in that course, but for now we're just going to leave it as inflection point. So much like our other parent graphs, as I take my HK value and shift it to the right, or if I shift it back to the left, you can see how you can just drag the whole graph around and everything is centered around that HK location. And when you take a look at the A, H, and K, you can also take that A value and stretch it up. And you can see how your A value changes. Right now it's at A equals 4. And that distance away from the x-axis is 4. And so your graphing form is going to follow the form of our others. Y equals A times x minus h quantity cubed plus k. So the difference between a parabola and a cubic is just this power. Everything else looks very much the same. And by making it the power of 3, you can see that it creates this S-curve. Now you can do all values cubed. Positive things can be cubed, negative can be cubed, etc. So our domain here is going to be all reals. So all real numbers for our domain. And as you follow this cubic function, you can see that it goes up forever if you go to the right. And even if I were to take my A value and shift it down so that it would be a negative 2, you can see we have our y values all the way in the positive and in the negative direction. That tells me that my range is also going to be all reals. Now you could use your interval notation here if you wanted to. So you would have to use the negative infinity to positive infinity for that same sort of concept with domain and range. Now symmetry, there is no line of symmetry here. There is rotational symmetry, but we're just going to be focusing on lines of symmetry, and there is no asymptote either for this particular graph. Final thing is to look at the Moodle syntax. You will be asked to write this into Moodle, so you want to keep it as simple as possible. A times parentheses x minus h to the power of 3 plus k. That's all you would have to write. You don't need any extra parentheses or multiplication symbols. Just have the a value out front on its own, and then put the x minus h in parentheses.